Okay, welcome back to CSE 391. This is our fourth lesson where we're going to introduce this concept of version control and a very popular tool that we use in version control called Git. Before we start, I want to talk a little bit about kind of like some logistics, what the rest of the quarter is looking like, and then we'll introduce this Git concept and how to use it. So kind of as a reminder of where we are, we've kind of talked a lot about, the mental model of a Linux system, how to run commands. We learned a lot of commands. We learned some really core ideas about command line arguments, input, output, and redirection, a bit of the input output between programs. And now we're going to start going into more applied spaces. So using specific command line tools that serve a very particular purpose. So for the next 2 weeks, we're going to be talking about one command line tool called Git that's going to be used for this version control system. And then we're going to talk about some applied skills and these things called regular expressions. And then we'll talk a little bit more about the Bash ecosystem with users and permissions and Bash scripting. But that's kind of like what the rest of the quarter is going to look like. And I'm going to mention that from the get-go, Git is one of the most fully featured and kind of complex tools out there. It is so powerful. There are so many things you can use with it. And we're not going to cover them all. Our goal is to give you a strong set of commands and skills that you can use for Git, such that you can use it effectively. And there are lots of things you can go explore outside of this class in the world of Git, and hopefully this gives you at least some terminology to explore those. Before I talk about this Git stuff, though, I do want to remind us that all of the core concepts are going to be covered in these lecture videos and on the Google Slides that I post on the course calendar. We have those live class sessions for Q&A, and I think those are really helpful because I don't know about you, but when I took this course, and pretty much any course, there is not a single lecture that I sat through. I was like, I have absolutely zero questions about this. Those Q&A sessions are designed to be there for you to clarify something that didn't make sense in one of these videos, because there are lots of things that probably don't make sense. And so we can spend some time talking about them, doing examples together. So I recommend you come to them, but we don't cover any required material there. All the required material is in these lessons, recorded lessons. So let's talk a little bit about some setup for why we're going to be talking about version control. So let's consider a few situations, and maybe at least one of them, if not all of them, have applied to you in the past. So maybe you're working on a programming project. Everything's going great. You're passing all the tests. And then you decided, oh, I need to make a few changes to my program to maybe meet some requirement, and everything's broken. And unfortunately, you never saved an old version of your program. And so now you're kind of out of luck. You don't have a backup. That could happen, but maybe they're lucky few that this has never happened to. But maybe one of these other contexts have applied. So maybe you've deleted a really important file and can't get it back. If you came to the Q&A session last week, someone asked in there, if you RM something, is there a way to get back? No, not without this version control thing we're going to teach you this week and next. Maybe your computer gets broken. Maybe you spill coffee on it, like I've done before, and you never backed up your files somewhere else. And maybe the one that's like the most relatable is whenever you're like writing a program or a paper for a class and you save final version, and you're like, oh wait, I need to make a few more edits. Final paper 2, just in case I want to see what I had before. And then, oh, final paper actually this time. And then you just give up and start naming it random things. There has to be a better way of managing versions of anything on your computer. And not just working on it alone, but working in teams, having some kind of version control system is going to be really, really important. Because if you've ever worked on even just a programming project, communication between kind of who has the right version of the code is pretty tough. Now, back in the day when we could meet in person, this wasn't the end of the world. A lot of times you just met up in person, you worked on a shared computer, maybe one of the CSE lab computers, and you kind of just coded in the same room together, talked about everything. Maybe you took turns typing on the keyboard. Now in the remote world, that's obviously not really possible. And so trying to have some way of being able to communicate changes to each other in a way that is efficient and also not cumbersome is going to be really important. Sometimes people just copy and paste code and send it to it. Maybe they send it in an email attachment. Heck, I've seen Some people send images of their code to each other and then retype everything out. There has to be something better than that. And maybe even trying to mark things as important, saying like this version of the files is the important version, the last working version. So having some way of communicating these is going to be really, really important. So that's where we enter version control software. So version control software could be anything, and it really is, and abstractly, just keeping track of changes to a file. Now we're going to talk about one particular type of software called Git. But while you probably aren't familiar with Git, you've definitely used version control before. So if you have Microsoft Word and you've ever typed something and then realized you spelled it incorrectly, you can always just press Control-Z or Command-Z to undo it. That's version control. Microsoft Word in the behind the scenes is keeping track of all your changes and lets you undo and redo them. Google Docs usually makes this at least a little bit more transparent, where you can actually click on the version history and see a list of all the versions. You can even go in and name them as special versions. So you're familiar with the idea of version control. Everyone needs this. We're going to talk about one particular tool called Git that's primarily designed for the version control of software projects. So code and the resources that go along with code. But lots of people have use cases for things like Git. Git is very flexible, it's very powerful. And so even if we normally will think about it being in terms of managing code bases, it's also used in lots of other industries. For example, some law firms use Git to keep track of their versions of their legal documents, or at least a program similar to Git. Keeping track of your research labs' progress, or like their journals, can generally be done in Git. So lots of people are using this tool. It's very ubiquitous. And it happens a lot through the command line, but can also happen in web UIs, which we'll talk about a little bit. So one of the core concepts in Git is this idea of a repository. A repository is just a project that you're going to have a history of. Almost always, we're going to call this a repo. So whenever you hear the word repo, you should think repository. It's talking about the software project or whatever project you're working on. We usually use repo because, sometimes repository can be hard to spell. In my lecture notes for today, I made like 4 typos with it, but repo, really hard to mess up. So that repo is going to be kind of the copy of all the project's files. Then you're going to have a repo on your computer. So for each project, each independent project you're working on, you might have a repo for it, so it has its own history. And on top of that repo, you're going to have your working directory. That's kind of like the files on your computer. Like you can edit files, etc. And one of the core concepts in Git is that you have to be a bit intentional to tell it, I want to commit this set of changes to a new version of the history. So Git works on this concept of a commit, which is saying, here's a set of changes. Please make a new version of the repo with these changes. And we call that a commit. The repo will store kind of whatever you want. It will store maybe your program files or maybe your build system files. I think we might have time in the end of the quarter to talk about these things called make files to help build your more complicated software projects. You might have images or things like there. Generally, there's a kind of rule of thumb of some things we don't put in repos that are managed by version control systems. Generally, things that are artifacts, things that like you might take your code and then compile it. So it might become a class file, or in the case of C, it might become a .o file. Those type of things we generally don't version control because they're kind of results of taking the current set of the files and compiling them. So anyone should be able to compile all your programs and get the class files back out. There's no need to keep track of all the binary that's inside them, and it will just kind of make most of your things messy. So there's some things that people by default generally think about not being included in version control, but we're not going to dwell on that too much. Now, I mentioned that this idea of the repo is very central to Git. So whenever we're working on a shared project, we each get our own copy, our own independent copy in some sense, of the entire repo. And so if we're working in a team of 3, developer 1 might have one copy of the repo, developer 2 might have another, and developer 3 might have their own copy as well. So these copies are shared in the sense that we are able to communicate changes between them, but in another sense, they're independent, where I can make my own changes, and if I never communicate with my partners, then they will never get my changes. So I have to be explicit in sharing my changes with other people. Generally, there is a notion of a remote repository, which is instead of having like one team member manage the true version of the code, we normally have this stored in a remote place. Usually this happens on a website like GitHub or GitLab, which you might have heard of before. These are just websites that their primary service is hosting repos. So they just provide you storage space to put a repo, and they let you push and view changes to them. And usually the way people treat these is that the remote, the thing that you store on GitHub or GitLab, is like the source of truth. That's where everyone's working from, or they're checking their changes against. And so we'll normally think about this, even though it's this very decentralized model, as being centralized at this remote location. Whoops. So what I want us to do is I want us to kind of, now that we've talked about in very abstract terms some of the Git terminology, I want us to start thinking about how we might use Git to manage a software project. Now, the way that this is going to work is, I think what might be best is to give you like a super high overview of kind of like the steps we're going to do. And then I'm going to have us come back and revisit the mental model, make sure we understand what we're doing at each step and why. So in this video, I'm just going to quickly show you a bunch of commands. I'm going to breeze through it pretty quickly as kind of like, this is what the standard workflow looks like. And at this point, it probably won't make a ton of sense what we're doing and why. That's okay. In the next video, we're going to come back and look at each step of what I just did once we saw that whole series of commands I just typed, and explore what each one is doing and why. Okay? So I'm going to just show you kind of the super fast version of how you use Git, and then we'll come back in the next video and explain what each one's doing and why. So I'm going to open up GitLab. So GitHub and GitLab, I mentioned, are just two places where people generally store software, these repos. This Allen School uses GitLab. We host our own version. It's the one we chose. So most of your CSE classes will use GitLab. GitHub is also fine. It's totally great. So I made this project on here. So this project has a bunch of files in it. You can see that there's this one file called product.java. It's a Java file. And GitLab lets me look at it and see all the files here. There's also a special file that most, kind of by convention, most places that host Git repos kind of use, is this file called readme.md. MD is a markdown file, and it's really just a special text file that gets displayed in a nice, pretty way. So the first thing we need to do if I want to work on this project, I want to make my own changes, is I need to clone the repository. So I need to get my own repo on my computer, because everything that's happening here is in my web browser, which is happening in like these CSE computers somewhere in Seattle. It might not even be there. It might be on GitLab servers somewhere else. So the first thing I do is I clone my repo. So I'm going to just copy that fancy looking URL. I clone it, and then we could see it has made a directory here. This directory, or this repo, is going to manage, we're going to start a new startup called Fang, which is not what if you've heard of that before, it's not what it sounds like. It's its own new startup that's going to replace all the other companies out there. And we're going to start by selling some products. Hopefully someone buys them. But this repo stores all the files I need to run my website. So you can see here when I ls in this directory, I see all the files that were visible on the website up here. So this is just showing me what files are in the repo. Okay. To highlight one thing, that none of anything I'm going to show you today is technically magic. There is, if you do ls-a, remember -a shows you hidden files. There's a directory in here called .git. And this is the internal structure of your Git repo that stores all of the versions, all of the internal files. You will never, ever look at this. It doesn't make sense for most people, including me. But it's all just kind of stored as metadata in there. So Git is not doing anything magic. It just stores a bunch of fancy files in that .git directory. So let's suppose I want to make a change. I don't know if you noticed, but in that readme.md, don't worry that my Vim had an error, but it's actually okay. In this readme.md, I had the quarter wrong. I said 20 winter instead of 20 autumn. So I'm just going to change that to 20 autumn. I'm going to save that. Oh, whoops. Type that command wrong. WQ to quit. I'm going to clear that away. Then I'm going to say git status. This tells me the status of the repository. Then I'm going to stage our file. So I'm going to say stage readme.md. This is telling Git I want to get ready to add something to our version history. I then say git commit. So I'm going to say git commit. And then I have to give it a commit message to describe what's going on here. So I'm going to say -m for message. And I'm going to say update readme. And then I'm going to push. And now, once I've done this, if you go to GitLab and refresh the page, you'll now see that there is now a commit up here that says update readme. And you can see that actual readme file now has that 20 autumn in there. So this was the pipeline. Make changes, stage, commit, and push. It sounds very convoluted why there's so many steps, but we're going to come back in the next video and explain what each of those steps was doing and why.